Okay, in this video we will learn about infinite limit. We will only cover the source which is important for us in this course. Where does that come from? I need to recall something that was very important for us in the section for limit. Uh, well, remember that when you have two functions f, and let's say both of them have limit L1 for f and L2 for g as x goes to a. Then when we were trying to find limit of the quotient of these two functions, there were two, at least at the beginning, two different possibilities. When the limit of the numerator L2 is non-zero. If the limit of the denominator is non-zero, we had what we called quotient law. And what we do is that limit of the quotient will be basically quotients of limits. But what will happen if the limit of the denominator is zero? Then we cannot use the quotient law because this will be L2 over zero. We are not allowed to put zero in the denominator. Well, this had completely two different uh, possibilities. If L1 itself is also zero, so the limit of the numerator is zero, the limit of the denominator is zero, then we had what we called 0 over 0 indeterminate form. And well, if L1 was non-zero, so if the limit of numerator is non-zero, limit of the denominator is 0, then we said that that limit does not exist. But if you look a little bit carefully on this case, where limit of the denominator gets smaller and smaller because it gets closer to 0, so limit of f of x over gx as x goes to a, this is the denominator is a small number, and the numerator getting closer to L1, which is non-zero. So this goes to 0, and as you can see, if you have a non-zero number over a very small number, gets closer to 0, approaching to 0, this will give us a big, either a large, either positive or negative sign. This is where the infinity limit comes in. Either it's positive infinity or negative infinity. This is called, such a limit is called infinite limit. When the limit of the numerator is non-zero and limit of the denominator is 0, we have infinite limit. But how do we know if it is positive infinity or negative infinity? So let me just write it here. How about the sign of the infinite limit? How about the sign of infinite limit? Okay, the sign is very important, and to derive that, to find it, basically we have to study what kind of zero is the limit of the denominator. So we need to study if the denominator approaches to 0 from positive numbers from the right. In other words, I can write it as limit of f of, the denominator. The denominator gx as x goes to a, is it 0 from positive, or it is approaching to 0 from the left? So limit of gx as x goes to a is 0 negative or 0 positive. Okay, so when you have that, everything is now, if you figure out if it is positive or negative 0, then you just multiply the sign of 0. Well, 0 itself doesn't have the sign. What we have here, 0 limit to the sign of the limit in the numerator, and that is the sign of the infinity. Very nice. There is one important point, that sometimes to be able to figure out what kind of 0 the denominator has, we need to study the right and left limit of function as x goes to 0. We sometimes, most of the times actually, need to study the limit as x goes to a plus and x goes to a minus separately. Okay, so we know that the limit is infinity if the limit of numerator is non-zero, limit of the denominator is 0. How do we know it is positive or negative? By looking at the sign of 0 in the denominator and the sign of the limit of the numerator. Let's do an example, or two examples. Example, find the limit. Okay, so I have two functions. One is that we are trying to find the limit of negative 3 over x minus 1 as x goes to 1. And then the other one is the limit of x minus 3 over x minus 2 squared as x goes to 2. While you have quotient, negative 3 over x minus 1, let us start finding what is the limit of numerator as x goes to 1. Well, that's negative 3, and that is non-zero, and limit of the denominator as x goes to 1 is 0. So limit of numerator is non-zero, limit of denominator is 0. That means that these two implies that the limit, we have infinite limit. We have an infinite limit. Well, okay, this is infinite limit. How about the sign? The sign, well, we need to separate the limits. Limit of x minus 1 as x goes to 1 negative. Okay, so here it means what? We are getting close to 1 from the left. So x getting close to 1 from the left. Then always x is going to be less than 1. That means that x minus 1 is going to be always a negative number. So it will be, the limit will be 0, but it will approach 0 from the left. And that means that limit of negative 3 over x minus 1 as x goes to 1 from left is, let me just write up here, negative 3 over 0 negative. So there's a negative sign up there. There is a negative sign coming from the 0 limit that gives us positive infinity. How about limit of x minus 1 as x goes to 1 plus? Well, we are getting closer to 1 from the right. X is always a number bigger than 1, and that means that x minus 1 is going to be always a positive number. So this will, x minus 1 will approach to 0 when x goes to 1 plus, but it will approach from the positive side. That means that limit of x going to 1 plus negative 3 over x minus 1 is negative 3 over 0 to the power plus. So this is positive, this is negative. You multiply, you get negative sign, and it is infinity. Very nice. That's an example. How about this other example? Well, you see the quotient, you always start checking limit of the numerator. As x goes to 2 is 2 minus 3 is negative 1, and it is obviously non-zero. And limit of the denominator as x goes to 2, this is 2 minus 2 squared, that is 0. Well, this means that we have infinite limit. But how about the sign and the sign? Here you see the denominator as x goes to 2, either from the left or right, doesn't matter. This guy is going to be either 0, 0, the limit will be 0, negative 0 or positive 0, yes? In other words, it will approach to 0 either from left or right. But when you square it, it will turn always to a positive number. So the limit is going to be always 0, but we will approach from the right. And that means that the limit of x minus 3 over x minus 2 squared as x goes to 2 is negative 1 over 0 plus, which will be infinity limit, but the negative of that. Okay, this was what you need to know about infinite limit. As I said, this is just the source of infinite limits for our course, which always comes from the quotient, limit of quotient function, and always you have to check if the limit of the denominator is 0 and then the limit of the numerator is non-zero. Well, that will give us the infinite limit, but we have to do these kind of things to determine exactly what is the sign of the infinity for those quotient function.